All right, so welcome to this 3.3 worksheet optional video where I'm going to help you out with some of these problems. So one tip that works for some students is actually label as you go. So segment WX is congruent to segment ED because they have the single hash mark. So I'm going to put S since they have a common side. And then I'm going to notice right after the side, both of these triangles have a congruent angle. And then finally, they have a third side that is congruent. So since the angle is the included angle, which means essentially it's directly in between the two sides, these triangles are congruent by side, angle, side. So that means triangle XYW is congruent to triangle DBE. It has to be written in that same order as triangle XYW is written in. Number two, at first glance, number two, all we have is an angle here and then an angle here. And as we learned that AA is not one of the theorems we use to prove triangles congruent. So at first glance, it's not enough information, but you should notice these two triangles share a common side. So that means the base of both of these triangles, they have it in common. So both of these triangles have a side in common. And again, since that side is the included side, meaning it's in between the two congruent angles, we can say the triangles are congruent by angle, side, angle. Notice the order they use the order of triangle PQS. So when we write our second triangle, we need to write it in the same order. So triangle PQS is congruent to triangle RQS. No other order works there. Pause the video if you need to. Number three is similar as the last problem. So you've got a side. You've got another side. So far you've got SS. But again, notice both of these triangles share a third side. They have a third side in common. So while we don't know anything about angles, we do know all three sides are congruent. Side, side, side is one of your triangle congruency theorems. So these triangles are congruent. And again, make sure you do the same order when you write your second triangle. So triangle ABC is congruent to triangle ADC. Number four, all you've got on number four to start with is one side and another side. However, you should notice you've got some vertical angles in here. And then you've also got some alternate interior angles, since those two lines there are parallel. So those two angles in green and these two angles in blue. So all three angles are congruent. AAA is not one of your options, but angle side angle is. So since we have an S, that's the included side between the two angles, we can say these triangles are congruent by angle side. Although technically, since we have three angles congruent in this problem, including this red one, we can also say these triangles are congruent by angle side as well. So triangle OST, match it up. Congruent to triangle OPR. All right, so number 5 is our first example where two triangles, we don't really have enough information on this particular problem to determine whether those triangles are congruent or not. Triangles don't share a complete side, they only share partial side there. And all we really know about these two triangles is they have one angle in common. And a single angle is not enough information to prove those triangles are congruent. So not enough info. Number 6, you should see it pretty quickly. This one is all keyed up for you. Side angle side. So I encourage you, pause the video for a little bit and try problems 7 through 10. I'm going to put the answers up here in just a second, so make sure you pause it, try the problems on your own, and then check. All right, so here are the answers. Check them before I head on to the last page. So on this next worksheet, on number 1, we're going to use a theorem that we haven't used so far. You'll notice these two triangles share a common side, but really that's all we can mark in this problem. Then we should be able to say that both these triangles have a 90-degree angle, so they have an angle in common. They have a side in common, and they've got another side, the one they share in common. You'll notice this isn't side angle side because the angle is not directly in between the two sides. Now, if this angle that I've got in blue was this angle, we could say it's side angle side because that's the angle in between the two sides. But it's not. So really what we've got here is SSA, which is not one of your 5 theorems. However, this is HL. HL means hypotenuse leg, and it only works for right triangles. So since these two triangles are both right, they have an angle in common, they have a hypotenuse in common, and they have a leg in common, they are congruent. So triangle BDF is congruent to triangle CDF. HL only works for right triangles. Go ahead and try the next few. I think you can do the next few. So practice those, pause the video, and I'll start putting the answers down in just a couple seconds. So there's the answers to the first 4. Check those, then we'll look at number 5 together. So number 5, you first should recognize there's nothing else you can mark in these triangles. But they do have an angle in common. They've got a side in common and another side in common. You've got to be careful what you're spelling here, but again, the angle is not in between the two sides here. If that A was in between the two sides, these triangles would be congruent by side angle side. But since it's not in between the two triangles, all you've got is SSA. SSA can work, can actually be HL when you have a right triangle, but here we do not have a right triangle. So really there's not enough information on number 5 to determine those two triangles are the same. We can't just automatically say the third side is congruent to the third side. And then you've got to be careful not to use HL in every instance there is a right triangle. So number 6, you might think, oh, it's a right triangle, so these are congruent by HL. But we don't know that the hypotenuse is congruent. We've got a side, we've got another side, and you've got the included angle. So these triangles are just congruent by side angles. If we also knew that the hypotenuse was congruent on number 6, we could also say these triangles were congruent by HL. But since we don't, all we can say is side angle side. Try those last few, pause the video, and try 7 through 10. So number 7, you've got the included side in between the two angles, so that's where we got ASA. On number 8, all you've got is an angle, and then a side. So then you got to think back, is SAA an option? Well, SAA is not. Just the backwards version is the one that we actually use. So these triangles are congruent by angle, side. So they have two consecutive angles and then a side congruent with one another. That's one of the 5 postulates we've talked about. So triangle PRW is congruent to triangle PRZ. And then there's the last couple of problems. Triangle DEF is congruent to triangle SAQ by HL. Number 10, you don't have enough information. All you have is an angle and a side, nothing else. Go and try the next 5. I believe you can do the next 5. Pause the video, and I'll show all the answers all at once here in about 13 minutes and 10 seconds. All right, so here's the answers to the first 5. All right, so number 6, they give you some information to fill in. First, they tell you angle A and D are right angles. So right off the bat, you've got one congruent angle. They also then tell you segment AB is congruent to segment DE. So you have an angle and then a side. And then finally, they give you segment AC is congruent to segment DC. So these triangles are congruent. You have to decide whether it's side angle side or HL. Of course, they do not have a hypotenuse in common, so this is side angle side. Go and try the last 4. There's the answers to 7 and 9, which I think were pretty doable. You had some vertical angles there on number 9. You had to mark to be able to answer that one. So number 8, they give us some information. They tell us WX is parallel to ZT, which means you'll have some alternate interior angles that you can mark congruent. on both sides. So you've got two angles, and technically you got three angles because you have vertical angles as well in this problem. But we need some sides. We're going to get that from this information here. They tell us XT is going to bisect WZ. So that means it's going to cut WZ in half into two equal pieces. So that means WV is going to be congruent to VZ. So this entire segment right here gets cut into two equal pieces. So really, again, this one, with what I have marked, I could say angle, angle, side. But if you use the vertical angle as well, you could have also said angle, side. Finally, number 10. So remember that upside down T, that means perpendicular. So they're telling us XY is perpendicular to AY. So here's XY, here's AY. So if they're perpendicular to one another, that means they form a right angle. And they say the same thing happens over here with BA and AY. So you've got two triangles that each have a right angle. I'm going to clear my diagram and just mark the angles. Really, that's all we know so far. The next statement gives us information about the segments. So XZ is congruent to BZ. And then finally, they say Z is directly in the middle of AY. So if it's directly in the middle, that means essentially it cuts AY into two equal pieces. This is not side angle side, because the right angle is not in between the two congruent sides, but instead this is HL. Only works for right triangles. You got a hypotenuse and a leg that are congruent with each other. So that's it. Practice those some more, and we'll take a test on this next week.